Hey, okay. We are going to talk today about transformations of radicals, and I want you to keep in mind that there's nothing new as far as the world of transformation goes. We're just going to apply what we already know to radical functions. So, all right, here's what we know. We know that this is the parent function of a square root, right? So the invisible index here is a 2 because, we're taking a square root. The graph of this thing looks like a smushed rainbow. It looks something like this, okay? And it kind of heads that direction. So you can see that everything has to be greater than 0 because we can't take the square root of a negative, and any square root is going to be a positive value. So the table of values for that, I want you to think really carefully about what our best bets are for some nice coordinates here, right? So we've got 0, 0, because the square root of 0 is 0, 1, 1, the square root of 1 is 1, and then we also like to take 4 and 2, right? So 0, 0, 1, 1, and 4, 2, because the square root of 4 is 2. So these are some really nice starting points on a square root function. Now, if we're going to do transformations on that, they're going to look a whole lot like they did on a quadratic function or a cubic function, but this time our radical sign is going to function as our inside. So where we had brackets before, we're going to use a radical. So it looks something like this. So our transformations are going to be negative a, so there's our vertical reflection and stretch, with our square root, a radical sign, and then a negative b, x minus h, and then a plus k at the end. All right, so here is my vertical reflection, here is my vertical stretch, here is my vertical translation. Do you see how they are all outside of the radical symbol? In here is my horizontal reflection. Here's my horizontal stretch, and here's my horizontal translation. Now, your mapping notation doesn't change. It does what it's always done, right? Like mapping notation hasn't changed at all. It still looks just like you would expect it to. It's still, everything on your x is opposite, so you've got negative x divided by b plus h, and then negative a y plus k. So nothing has changed. So let's do a couple examples of what that looks like. So let's say we have y equals the square root of x plus 2. So this plus 2 is horizontal, it's a translation, and it means it's going to go 2 to the left, right? Because we're going to do opposite math. So you're going to take that, and remember, we originally said you had 0, 0, 1, 1, and 4, 2. So we're going to slide that whole thing over 2 spots, right? That's all it's going to do. We're just going to slide it. We're going to slide it to the right. Same deal if we had like the square root of x plus 3. This is just going to raise the entire thing 1, 2, 3 spots. So our 0, 0 is now up here at 0, 3, and our 1, 1 is going to be up here at 1, 4, right? Oops. So it looks like this. Now listen, you can do mapping notation on this, and these are like pretty straightforward, but they're going to get more complex, and mapping notation would be good. So always for your parent radical, I like to use 0, 0, 1, 1, and 4, 2. So let's look back at this top one. So that means here you needed to subtract 2 from all of your x's. So your x's were going to become negative 2, negative 1, and 2. And then none of your y's were changing, right? And you would do that same idea here. So these are kind of these like table of values that are more like table of coordinates, if you will. Okay, Same thing on these, like if you have y equals the square root of 2x plus 4, what do you need to do here? You need to factor because it's inside. Don't let that get you. So when you rewrite that, you're going to rewrite it as the square root of 2 times x plus 2. So now you can see you've got a horizontal stretch and a horizontal translation. So on our mapping notation, we're going to have x divided by 2 minus 2. There's nothing vertical. So we're just going to leave our y alone. And if we make our table of values / coordinates, remember we had 0, 0, 1, 1, and 4, 2. So now we're going to have 0 minus 2 is negative 2. A half minus 2 is negative 1 1/2, and 4 divided by 2 is 2 minus 2 is 0. And then all of our y's, again, stay the same. So really, this is nothing, again, not new information, nothing new here. We're just applying it to a different shape function. And we should know radicals pretty well. Okay, so that's how that works. Oh, we didn't talk about reflection. Real quick, reflections are a little bit different than they've ever been. That's true, although not new information. So if we have y equals negative root x, this is going to be, here, let me show you our 3 options. So we have y equals negative root x, we have the square root of negative x, and then we also have a double, like negative square root of a negative. And remember, our original parent functions are here. I'm going to draw all my original parents in red. Okay, so if I reflect this is a vertical reflection. If I reflect that, it's going to do exactly what you expect, and it's going to reflect vertically and go this way. Okay? This is a vertical reflection. This one is a horizontal reflection. It's going to do exactly what you expect it to do, and it's going to reflect over the y-axis and head this direction. This one is double, okay? So here we have a vertical reflection and a horizontal reflection. And it is going to initially, let's say we do our horizontal, it's going to do this, and then that's going to reflect down here, and here's what we end up with. Okay, so that's a little different than our quadratics, because our quadratics didn't always look different when we reflected them horizontally, but now you can really see that reflection. Okay, so let's talk about cubic functions, or cubic roots. So a cubic root is new, and a cubic root is when you have a 3 for an index, all right? So, and the reason that this is new is because if you can take cube roots of negatives, right? Like, what's a cube root of negative 1? Well, it's negative 1. Because think about it, negative 1 times negative 1 times negative 1 is negative 1. And you can take the cube root, oh my gosh, okay, you can take the cube root, not of negative 4, but of negative 8. Because what's the cube root of negative 8? It's negative 2. Because remember, negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4 times negative 2 is negative 8. And then, oh, duh, we can take the cube root of 0. It's 0. But we can take the cube root of positive numbers too. So the cube root of positive 8 is 2. And the cube root of positive 1 is 1. So what this is changing the game on is all of a sudden negatives are back in business. So if I take all of this mess and I turn that into a table of values, all of a sudden my x's can be negative. So I can say negative 8, negative 1, 0, 1, and 8. So what are my y's here? So I'm going to have negative 2, negative 1, 0, 1, and 2. And if we graph this, think about what that looks like. So if I graph -8, -2, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, I have a point right here, way out here. -1, -1's here, 0, 0's here, and then 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, and then 1, 1 here, and then 8, 2 out here. So this is going to give us this curve. I did a terrible job drawing that. It's going to kind of give us this like sideways S, which, if you will notice, looks a whole lot like a cubic function that fell on its side. Oh my gosh, I completely missed. Okay, so this is the parent of a cube root, okay? And these are our coordinates that we're going to really rely on to help guide our transformations. So this is the parent of a cube root, okay? Here's our function. Remember, in cube root, you need to draw your 3 as an index. And here's our graph. So we're going to do transformations to that, and it's, again, nothing new. We're just applying it to something new. So let me write that out like really clearly. So cubic, oh my gosh, I can't spell it all. Cube root transformations look like this. Our parent is y equals cube root of x, and what we like to draw on that for x and y, one more time, is -8, -1, 0, 1, and 8. These are really good coordinates, which gives us -2, -1, 0, 1, and 2. Transformations look like this. They look like y equals -a, radical sign with a cube, -b, x minus h plus k. They look just like the square root functions. The only difference is your graph has a different shape, and we're going to use this set of points because it's not that like -4 doesn't exist. It just doesn't give us a really nice number that's easy to work with. We're setting ourselves up for success by picking these really nice, perfect cubes. Okay, so a quick couple examples on that. So for example, if I say y equals the cube root of x plus 2, I'm going to take my graph and I'm going to raise the entire thing by 2 units, right? So I'm going to graph my 0, 0 is now going to be up here at 0, 2. And it's going to just move up 2. All right? My mapping notation on this would have been x and then y plus 2. Same mapping notation we always have. We're just taking that shape and we're raising it 2 points. If it reflects, if we have y equals the negative cube root of x, what do we expect that to do? We expect all of our numbers to flip over. I'm just going to pick 3 points right now for the sake of time. So remember, like if this is what I originally had, and all of my y values are going to flip, I'm going to now end up with -8, 2, 0, 0, and 8, -2, which means all of a sudden I've got this. Too bad I can't draw it all. I do better if I start from the middle. And it just vertically reflects like that. Okay? That's That's yeah, that's all that's happening. Okay. So I think other than learning this new shape and these new points, it's not the transformations that are getting you. So really make sure you've got this whole page down. And I think you'll be able to go from there. Okay, best of luck.